Welcome everybody. This is going to be a technical presentation on the new Wire EDM, and actually a comparison between the old Wire EDM and the new Wire EDM, and what's changed and what stayed the same, and that sort of thing. The format of this, how I'm going to do this is I'm going to show you how to do it in the old system, and then I'm going to transition to the new system. Hopefully you'll see the differences and as well how many things have changed for the better. So with that said, I'm going to move right along here. So this is GibbsCAM 13. We're going to be using the old Wire EDM here. And the old Wire EDM is based off of geometry only. So it only looks at geometry. And there's a couple of disadvantages to this besides the fact that it's just harder to work with. One disadvantage is that if the model is updated, something changes with the model, you basically have to restart. You have to go back to the solid model, you have to re-extract geometry, and you're going to have to reprogram the part as well. With the solids-based method, which is what we're moving towards in the future, when a design change is made, it will automatically update, and then the toolpaths will automatically update as well, be regenerated. So that's a huge advantage there, one that we're not going to see in this demo, but with that said, let's go ahead and move on. So I'm going to start extracting our geometry here. And I'm going to be doing the inside and the outside of this part. I know that sometimes people just do the inside, but so I've got my geometry here, and in addition to what I've extracted here, we need some points for start points for our toolpath here. So we're going to open our geometry palette, point, mouse point, and I'm just going to make some approximate points here to start for each pocket. Trying to get it in the middle, but it's not exact. Now, if I normally did this in real life, I would probably be actually entering X and Y values, but just for the purpose of this demo, I think this is good enough. Okay, so we have our start points here. So now we're ready to go to Wire EDM, launch all visible, and it takes all the wire geometry and pulls it into this separate application, the Wire EDM application here. So without further ado, let's get looking at this. So we start with this top icon here. Click this. This is kind of your document control, how you set up your machine, all that kind of thing. So we have all our post processors here. I'm going to stick with the Xiaomi here. Now we can edit the wire diameter, the material that we're cutting here. I'll leave it on aluminum for now. I'm not going to dwell too much on this, but there is a certain amount of time investment that goes into setting up this dialog box. You can see there's multiple tabs here. If I go to the machine strategy tab, I can say reverse alternate cuts if I have any, some glue stop options. If you're not familiar with glue stops, it's the same thing as bridges, and I'm going to be using that terminology later as well. And so we have a couple, if we're doing multiple parts, multiple cuts rather, what order do I want to do them in? Do I want to go back and cut the glue stops or the bridges later? All that kind of stuff is controlled in this dialog box. I'm not going to dwell too much on the old Wire EDM as much as I will on the new one. So let's get started. I'm going to kind of skip past that. We have create or edit a wire part, and once I click this, you should be able to see kind of at the bottom of the screen, it's asking me to select a profile. So let's start with this top one, and when I click it, I get a pop-up box here. I can change the number of cuts that I want, what kind of cut I want, and I'm going to leave all that at default, and I'm going to select a start point, the start point that I created earlier. Okay, go ahead and say OK, and then when I say OK here, it turns red, signifying that it has indeed made a toolpath there. So I'm just going to continue on doing the same kind of thing with all these other shapes here, selecting our start points and creating our toolpaths. Okay, so this is a fairly simple example. We're going to get into some more complicated things a little later. Start you out easy. Okay, Cool. Well, we also have our outside perimeter last here. Okay. So now we should effectively be done. If I rotate the screen a little bit here, you can see that there's some height to this. So the red is actually our toolpath, and effectively the purple is what's going to be cut. So that's kind of what it's going to look like once we're finished here. So let's go ahead and simulate this, see what it looks like. All right, so we started with this pocket, and it's actually doing this in the order that I machined it in, and that's probably not the optimal order, right? So let's go ahead and fix that. Down here towards the bottom, we have a reorder, resequence operations. Okay, so let's get a top view again. It kind of resets when you change the view. So let's do this first. Second, third, fourth, fifth, and then we'll end on the side here. So that'll be our route here. I think that's about as optimized as we get. And say OK. Cool. So now, once I re-simulate this here, I think things are a little flipped around. But that's how you reorder it. So one of my biggest complaints with the old Wire EDM is if I wanted to change any of these operations, it's kind of a pain in the butt to go back and do that. If you're familiar with GibbsCAM, there's typically tiles on the left-hand and right-hand side, and I can go back and edit and change them and overwrite or completely make a new one. There's a lot of power to being able to do things with that methodology, and there's really not a good equivalent here in the old Wire EDM. So I'm just going to leave you with that, and let's move on to our new Wire EDM module here. So it looks almost identical. We're going to be doing the same part here, but hopefully you can see with this solid base methodology that OPTICAM has developed how much quicker it is. So the first thing new users will want to do is go into your plugins menu and plugins manager. And down here in O, we have OPTICAM Wire EDM here. And just make sure that's checked on, otherwise you're not going to be able to do anything with Wire EDM. Once that's checked on, you don't ever have to go back and check it on again. This is a one-time thing only, but I just wanted to point that out. Okay, and once that's checked on, you have an OPTICAM toolbar that drops down here, and everything's grayed out. And the reason is that I'm not using a compatible machine. So if I go to my document control, we can see that we have a 3-axis vertical mill. I'm going to set this to something that's compatible with Wire EDM, like our vertical Wire EDM here, okay? And as soon as I change that, you see that the interface kind of changes. So OPTICAM has separately developed this besides GibbsCAM, and it's a plugin that goes into GibbsCAM, which is why we have a different interface here. So after you've set up your machine and everything, kind of forget about GibbsCAM and how to do it. But this new interface is really easy to use, and I think you'll see that here in a second. So if I want to machine this, all I have to do is go to the OPTICAM menu, and then I'm going to click Feature Recognition. And I get the option to do, hey, do I only want to do the internal features? Do I want to do the external ones? In this case, I'm going to do both, because I did both in the other one, right? And then I hit this green check mark, and my part's machined. That's it. That's all there is to it. It takes all your settings and all the way things have been set up and just applies them to the new one. So just so you can see what it did, let's do a simulation of this. And this is completely out of the box. I haven't gone through and messed with any of my settings. I think that it does a really good job here. So let's start. It starts at the origin. It's going to come over to our first slot. Let's speed this up just a bit. It threads the wire. It starts in our start points that have been set. These were actually created in the CAD program that created this model. They just created a surface, and it doesn't matter what size that is as long as the surface is within the feature that you're trying to machine. OPTICAM will recognize these and automatically use these as start points. So it gives you a lot of control over how it does it automatically. Now, if I didn't have these surfaces here, it would create one based upon my default parameters. So this is kind of a way to get around the default parameters without actually having to change anything, but I'll show you how to do it the official way later. Let's continue on. It waits for me to cut that bridge. That's what it was stopping there for. So I can remove the slug, continue on. You can see it automatically retracts the wire, and then automatically brings it back when it goes to over the proper slot here. Okay, and you notice that our order is pretty good right off the bat, which I like. Not a lot of reordering, but it is actually pretty easy to reorder, which I'll show you here in just a second if I do need to reorder this. Okay, and let's finish up with this. And we got our outside as well. All right, perfect. So all of that was done completely automatic, and I'm going to show you some of the behind the scenes options that you can change, but really the default settings are pretty good. I wouldn't be too worried about. You saw how it automatically does the waits for the bridge to cut, it automatically threads your wires, it really does everything behind the scenes. So with that in mind, let's kind of continue on through how this is done. So I'm going to start off by going into our origin. Now this is how you move the origin. It's a little bit easier than how you do it in GibbsCAM. You can just click a vertex edge. I want the origin to be, and anywhere I click is where it's going to go, but it has to be on the model, so to speak. So I can't click here because that's just my stock, but I could click here if I want it there or here, or, you know, it's pretty easy to move your origin around. And if I don't want it there, I can just hit the X button and it'll go back to where it was. And so that's nice. Now, when you import a file, import a part into the file, it automatically centers it at the bottom. So, and I think typically with Wire EDM, that's what you want to do. That's generic standard practice, but it's very easy to change if you don't want to do that. As for strategy, this is your overall strategy for cutting the entire part. And there's really nothing here because it's looking for you to do it on an operation by operation basis. So this is just empty here. I'm going to continue moving on. Technology. So this is actually how we're going to be cutting the part. Okay, and this can get a little complicated, but basically you can set it up once, and then no matter what, it will continue to machine with those parameters once you load them in. Okay, so right now we're using a 25.25 millimeter wire with a brass wire, cutting steel, and all this stuff is kind of auto-populated here. If I wanted to change this, I wanted to do something different, I check this box here and I say Cuts Editor, and that allows me to come in here and kind of turn these on and off, that kind of thing. So let's say that I want 3 cuts. My first cut I want to be offset 0.3 millimeters from the edge, maybe my second one 0.25, and then my last one 0.2 or something like that. These generator registers and offset registers has to do with how it's posted. So I'm just kind of putting in good values for here, but that's not necessarily too important on how this is done. Okay. And you can see I can kind of like control this pretty well. Let's say, for instance, that I wanted to, I'm concerned about the feed rate on the first operation. So I check the feed rate box over here, and that allows me to change the feed rate that it automatically does for each cut, right? So let's, on this first cut, just because it's the first one, let's change this to 7 millimeters per minute or something like that, right? And then when I'm all done with all of this, I can just go Save User Tech, and I can give it a name, User1 Tech, just something meaningful for how you're cutting this, right? and then you can save it. And for future parts, anything else I do, I can just go in. I'm not going to save it in this case, but I can go in and I can say load template and then load that back in for any other part that I do in the future that I want to be machined the exact same way. Okay, so once you set it up, you might never have to set it up again. And then in addition, there's some extra options that I think I'm going to show you on the next part. But this is a good little intro to how this works. And so when I change this technology, because this technology up here, everything is owned by it, right? So now if I go back to any of these other operations and kind of zoom in, it's doing 3 passes. So I didn't have to regenerate any of these operations. It's all done automatically. And that's really the theme of this new Wire EDM, is everything's pretty much done automatically. Moving on to our workpiece, this is our stock, rather, and the standard setting is that it makes a box around your solids, and then it offsets by whatever you put in these dialog boxes here, right? You also have the option of using specific solids, so maybe I had done some milling work on my solid before, and I don't want to remake holes or something like that. I would import that solid here, and I would choose it right here, and then I would use that as my stock. Okay. For the purpose of this, I'm going to leave use box around solids. Okay. And so these origins and that kind of thing are a subset of the master one here. So I don't have to move my origin again. That's already done. If I did want to have a different origin for a specific operation, that's where I would do it here. Okay. Strategy. This is basically about reordering our program. Now, I think it had the optimal path right off the bat. It does look at the length of the path and it optimizes before it creates these paths. However, you have some manual control over this as well. If I've said, hey, I want the shortest path between features and I want to manually do that, one thing, and you can see the path now, so it's going, it's starting there and going around here, and this is the suggested shortest path. Okay, and it gives you the length of your toolpath in case you're splitting hairs here. But I can overwrite and say, hey, I want to start here and I want to end here, and then say calculate new, and it'll recalculate a path. And you can see that this path is 7 millimeters shorter than our old path. So we've made a little bit of progress, but it was really easy to do that. I didn't have to individually click each pocket like we did in the old one. So that's nice. That's a cool feature. We also have some other features, options down here: collar before taper, taper before collar. I don't have time to go over all these, but a couple things that I like is cut bridges at the end of the operation. I also like reverse cuts when possible, when we're doing multiple cuts. But that's all preferences you can set on a part-by-part basis. Okay, and again, there's no regenerating. When I change things, it's automatically changed. Technology, this is using the program technology, which we've already talked about up here. Workpiece, this is going to be using the workpiece up here, so there's no reason to change that. So really our part's done. I do want to point out that there are some extra options within the individual parts here. So like this one, for example. So I'm just talking about this cutout here in the upper left. I have options to do before move. So before it starts this, I can say, hey, add moves here. And you can see that it's already rapiding from the origin here, but maybe on this one, my step 2 rather, I want it to automatically thread the wire or something. So you can see rapiding from the origin over here, and then it's going to thread the wire. So you have a lot of manual control over what your machine does. However, all of this is already done automatically. You saw from the simulation before, it automatically moves from the origin, automatically threads the wire, automatically cuts the wire. So this is kind of redundant. There's really no reason to do this. I just wanted to show you that you can override. Okay? You can change the technology on an operation by operation basis. Lead in, lead out, right? So we have a lot of control over that. I can say, hey, you know, I want to arc in or something like that. So a lot of control here as well. I'm not going to mess too much with that because we already have our start points. Okay. Corner relief, that's another good option that we have. So this one already had the corner relief built in. But if I didn't, I could say, hey, I want circular loops on each of these corners, and then I can define the radius of the loop and that sort of thing. So it kind of saves your designers a lot of time as well. Okay. You also have a pocketing option if I wanted to actually destruct this slug in here. And then we have, similar to before moves, we have after moves for each segment. But that's it. That's really, I didn't change much. I just OPTICAM feature recognition and our part is done. So that's that. Really cool stuff here. I'm going to go ahead and close this old Wire EDM here, and let's move on to a more complicated part. So I'm going to say new part. I don't care what I'm calling it. And let's import a 4-axis part here. And when you import parasolids, sometimes the tolerance import height is pretty low, so I like to bump this down. This doesn't have any effect on your toolpath. It just makes it look nicer. So, and then one more thing before I get started here, I'm going to modify shrink wrap, get our stock all set, but we should be good to go here, good to start. Okay, so like before, what we need to do, and this is a 4-axis part. Let me show that off here. So there is some draft about 5 degrees to this part. Okay, so that's what makes this different from the last part. We're going to need to extract the edges, same reason the last time. And on this part, I'm not going to be doing the outside, so let's delete this because I don't want anything to come in that's not needed. Okay, doing the same to the bottom. The reason for that is that the shape on the bottom is different from the shape on the top, as you can see right here. So we need both of those shapes. So with that said, our last step before we can jump into Wire EDM is making our start points. And I'll do one right there. Okay, and we should be good to go. Let's move on over to the separate Wire EDM application. Okay. All right. I'm going to skip over all this dialog box again. Again, I think people just really care about the new one and not the old one. I just want to show how much is better. So let's skip over that for now. Let's start right with creating toolpaths here. So create our wire edit part. I want to select this profile. And this is going to be a 4-axis this time. So I check this box. I want to select my lower profile, click down here, and then I also want to select my start point up here. You have to be very careful about what you're selecting because if I accidentally select in this black area, it's going to unselect things that I've already selected and cause me to have to restart. So it's a little bit picky, but there we go. And all these lines, because it's 4-axis, are effectively like this surface. And this is all wireframe geometry, as I mentioned before. So this is kind of a fake surface that it's created for visual purposes here. But if I'm looking at, let's say, this part here, this isn't right. So the lines are going straight down, but we know that there's a draft, so they shouldn't be going straight down. They should be at a proper angle, right? So really, this point connects to this point connects to this point, and we have to fix that. It doesn't know that based off of what we've done so far. So we have a button down here that says Add or Edit Sync Point, and I'm going to click that, and it's asking me to select the upper profile. I'm going to select this, and then I'm going to select down here where it matches up, right? I'm going to select this, and then I want to select down here where it matches up, okay? And then once I right-click, it's going to get out of the command and kind of update, and you can see that this is how it's supposed to look, okay? And I'll do a few more, but effectively, if you were really doing this part, really programming this part, you'd have to go all the way around the part, okay? So I'll just do a couple more. but it's kind of hard to see what I'm doing. There's a lot of room for error here, if I'm being honest. But that's how these ends are supposed to look, okay? So you get a nice little before and after here, how it's really going to look. You can tell if these are kind of not crossed, that sort of thing. So I'll go ahead and simulate this real fast, but just be aware that if I were actually doing this part and I had to go all the way around, set up these dialog boxes, it would take a pretty good deal of time. And I don't want to kill my own thunder here, but of course the new Wire EDM product is going to be significantly faster, significantly better, and also have significantly less room for manual error, user error, right? So that's that. I'm going to go ahead and close this. We're done with the old portion of this demonstration here. So let's go back to our GibbsCAM 14, and I'm going to start a new file here. Actually, I'm going to close my old one here and start a new file on GibbsCAM 14. It doesn't matter what I call it. Okay. So it remembered my machine. Let's import that same file. This comes in just like the other one. I'm going to make it look a little better. I'm going to shrink wrap my stock just to get that out of the way. I don't want to have to deal with that. Okay, so now we're ready to program here. This time, just to show you something different, I'm going to go to manual feature recognition. And part of the good thing about manual feature recognition is it's only going to do one feature, right? So it's not going to do the external. It's going to do whatever I click on. And then also this helps control where I want my starting point to be. So in this case, I want my starting point to be on this face. So this is the face I selected. You can see that it automatically created that ruled surface there for my starting point. But that's it. And then I hit the green check mark, excuse me, and it should all be done. Let's check that out. Let's see if I'm correct here. And you can see it's automatically angling, automatically following that line. It actually automatically detects if this is a 4-axis part or a 5-axis part. If it's a 5-axis, it'll error out, say, hey, you can't do this with the wire part. It'll let you know that this surface isn't straight. All right, and then it does the same kind of thing. And that's it. So again, this entire part took me, I don't know, 15 seconds to program. And if you had your technology set up beforehand, if you have like a company standard, something like that, it really does only take 15 seconds to program your part. So a little bit of improvement there over the old system. Just so that you guys can learn a little bit more, I want to continue on some of the nitty-gritty details of things that we can do in the new wire axis here. So let's look at post processors. Now, post processors are one is included when you purchase this GibbsCAM Wire EDM module, okay, and you get to tell them which one you want. But effectively, all the post processors are already built into the system, which is actually really nice, and I'll explain why in a minute here. So let's do a Mitsubishi manufacturer, Mitsubishi post processor. I hit this load post processor button, and there's actually within this post processor like kind of a database of techniques and technology and that kind of thing that comes in here. And so it's asking me, you know, what database I want to load in, and this is specific to Mitsubishi. You see they have their logo here, so it's only going to pull in things that are compatible with the Mitsubishi machine. Now, once I do that, I go back into here. It should be loaded up here, and I can select the type of Mitsubishi machine that I want. I'm going to go with the FXA here. And once again, I can load this in. And now you see program Mitsubishi. It knows what kind of machine we're working with. We're all set to post out. So that's that. But really, one cool thing that does, besides the post, is now if I go into my technology here, we have the Mitsubishi logo here, and I can load technology here. And this is effectively like a search engine. So it's searching the database of post processors and cutting methods and everything that's in here that allows me to, this is the database that it's searching. It allows me to search for certain things. So in this case, I'm going to be using a brass wire material. I don't care about the wire diameter. You know, I have a couple different kinds on hand. I'm just going to leave that blank. But I am cutting steel. And let's say, you know what, I want to do 3 cuts. Okay, and then I'm going to hit the search button, and it comes up with a list of all the different pre-populated cutting methods that's in the database that are compatible with this type of machine. And I can select these, and whichever one I double click, it's going to ask me to confirm. I can say OK, and it automatically populates all of this. So you can see that this particular method has 3 cuts. The first cut is coming off about a 0.14 millimeter off the side, and then it's getting progressively closer. And this is going to apply to any operation that I do. Okay, so now if we go back and look at this operation that I already generated previously, you can see that we're now doing 3 cuts. I didn't have to regenerate. I didn't have to change anything about the model or go through any kind of thing. All I had to do is load in the previous work, and it just works here. So let's actually simulate this one more time. I'm going to do a graphic simulation instead of a solid simulation. The main difference being it doesn't ask me to remove plugs, and I also believe it doesn't stop. Speed it up a little. All right. And I also told it to do 3 cuts. So it's going to automatically reverse the direction. Again, I already showed you where to change that. But all this is done automatically. I think that's really cool. It's a million times easier than the old Wire EDM, where in order to regenerate an operation like that, I have to actually go back and delete that old operation and kind of restart. So miles ahead of where we were with our old one. Couple more things I just want to show you while I have you here. These settings here in the OPTICAM settings menu, these are all kind of things that you set and probably won't touch again, but they might be worth looking at once or twice. Your units, you know, geometric tolerances, all this kind of stuff. We have a feature that's coming soon in a later release called color settings. And basically, in your CAD program, what you can do is apply colors to different surfaces in your model. And then when that model is brought into GibbsCAM, it recognizes colors. And depending on the colors that there are, so like yellow will be, I want you to cut this surface like with these methods, right? So using a different technology, versus a blue color might denote that, hey, I have different tolerances, I want this cut a different way. And all of that works in conjunction with automatic feature recognition and will automatically change your technology based upon what you need. This requires a little bit of setting up, but once you do it, like I said before, you could actually really have your interns programming parts. It's that easy. So this is a feature that I'm excited for in the future. Should be coming here somewhat soon. These start hole settings are how the start holes are automatically generated depending on the different shapes. So here we have a weird X that's not going to be in the thing, but you can see we have a good amount of shapes to choose from, where I can say, hey, quadrilateral. So if I have any kind of quadrilateral, I want you to start 2 millimeters from the longest side, right? So there's really a lot of power in how you can just set things and then leave them be and never come back to this menu again unless you really find that something's not working automatically. But in my experience so far, all of this has been pretty spot on with the generic settings. So don't dwell too much on that. feature recognition settings are actually, you know, hey, what do I want it to recognize? Maybe I don't want to do any 4-axis, so I would uncheck that, and when I run feature recognition, it's not going to find any features that require 4-axis machining. Okay? You can look at the rest of these settings a little bit later. There's just too much to go into in a short video like this, but that's that. And I think for the most part, that's basically everything in the new Wire EDM. Hopefully you guys saw that this is just a million times better product, and I'm really excited for new users to start using this. So thanks for coming to my demonstration, and I hope you learned a lot.